Hello everyone. In this lecture, we are going to learn about a simple life cycle model. But before we get into this model, let's take a look at a process that you might be familiar with, like building a house. So if you were to build a house, what you are going to do? You will probably reach out to a builder and tell about your needs like I need two bedrooms, or I need a bigger great room, or I need a room on the basement, or there could be many more specifications. And builders may give you some options, and then you will have to do some analysis and come back with your choice. In the end of this phase, you will come up with exactly what you are looking for. Then builder is going to go back and going to create a floor plan, and then he's going to show it to you, and you might make some adjustment. Once this is done, builder is going to create a detailed map or detailed plan about where the foundation is going to be, where the electricity is going to be, where the plugs are going to be, where the plumbing is going to be, and so on. They are going to start the building, and as they are building the home, they are going to call the inspection people to come to inspect the house. For example, let's say the foundation is done. They are going to get the foundation approved, and when the plumbing is done, they are going to get the plumbing approved, and so on. And once the house is ready, he is going to call you to say whether you like the house, is it what you expected, and then once you approve it, you are going to stay on that house. And here comes the maintenance of the house. Let's see how software development is similar or different than this. So when you are building a software similar to building a house, you are looking at requirements, or you are looking at what exactly you need to build. And during that time, you will do analysis of different options, or you might do a prototype and show it to the customer, and you can say, is this what you are looking for? But at the end of this phase, what you have exactly what you are looking to build. Then comes the architects and the software developers. They are going to design the system, they are going to architect the system, and after that they will work on different components of the system. And once the design is done, they are going to start coding, and they will start unit testing. So each of the sub teams are going to start building their components and test it. Once all the components are ready, they are going to bring all of these components together and do integration testing or card verification. And they will do functional testing as well. And when the software is ready from the developer point of view, then they are going to invite the user, and they will do a testing. It's called user acceptance testing, in which a user say, yes, this is what exactly I was looking for, or no, this is not what I was looking for. So, and then once everything is done, then the software goes into production, which means the user is going to start using the product, and they might ask for some changes. So you have to fix those changes, you have to fix those defects, and so on. So that's called the operation and maintenance. So now you can see it's quite similar to building a house. So the model that we are just talking about, it's called waterfall model. So here everything goes from phase to phase. So we will learn about this model in details later. But here they have depicted 5 phases, and those are requirement, design, implementation, testing, and maintenance. Those are 5 phases here. So in this figure, they have shown that everything is going sequentially. So that means once a phase is done, they are going or moving to the next phase. But for a given project, these activities are not necessarily separated as strictly as indicated here. They may and usually will overlap. It's quite possible to start implementation of one part of the system while some of the other parts have not been fully designed yet. And we can also backtrack to earlier phases. So now we will talk about these phases in details. So the first one is requirement engineering. So the goal of the requirement engineering phase is to get a complete description of the problem to be solved. Requirements may include hardware and supporting software, or the number of prospective users of the system to be developed, or the functions of the software to be developed, the possible future extensions of the system, the amount and kind of documentation required, the response time and other performance requirements of the system. So those will include in requirement engineering. But one important thing in requirement engineering is a feasibility study. So it is the purpose of the feasibility study is to assess whether there is a solution to the problem which is both economically and technically feasible. So that's why we do a feasibility study. Here comes the design phase. So the design phase is very crucial. During this phase, a model of the whole system is developed, which when encoded in some programming language solves the problem for the user. So here, early design decisions have a major impact on the quality of the final system. So during the design phase, we try to separate the what from the how. We concentrate on the problem and should not let ourselves be distracted by the implementation concerns. The result of the design phase is the technical specification, which serves as the starting point for the implementation phase. So in the implementation phase, we concentrate on the individual components. Our starting point is the components specification, which is the output of the previous phase. And it is important to note that the first goal of a programmer should be the development of a well-documented, reliable, easy to read, flexible, correct program. The goal is not to produce a very efficient program full of tricks. So the result of this implementation phase is actually an executable program. So now if I say that then comes the testing phase, it's wrong. I should not say after the implementation phase, here comes the testing phase. It's wrong. It's not like this testing phase is not the following phase. We should not think in this way. And that's the biggest mistake you can do. We should pay attention to testing even during the requirement engineering phase, the first phase. During the subsequent phases, testing is continued and refined. The reason behind this is the earlier that errors are detected, the cheaper it is to correct them. So testing at phase boundaries comes in two different flavors. We have to test that the transition between subsequent phases is correct, and this is known as verification. And we also have to check that we are still on the right track as regards fulfilling user requirements, which is called validation. And then the maintenance phase. After delivery of the software, there are often errors that have still gone undetected. Obviously, those errors must be repaired. In addition, the actual use of the system can lead to requests for changes and enhancements. All these types of changes are denoted by the term maintenance. So maintenance thus concern all activities needed to keep the system operational after it has been delivered to the user. So the figure here, it's the relative effort spent on the various activities up to the delivery of the system. From this data, it is very clear trend emerges, and that's the trend is called 40-20-40 rule. Only 20% of the effort is spent on actual programming, that is coding the system, while the preceding phases like requirement engineering and design and testing each consume about 40% of the total effort. So that's why it's called 40-20-40 rule. So that was all for today. Thank you for watching.